All right, young scholars, this week we're going to talk about exception handling and its relation with text input output. Whenever you see I/O in programming, it refers to simply input output. The idea of exception handling is to, in essence, debug issues before they occur. You've probably seen a situation where you're using Excel where you might have had a div O error pop up in one of the cells. That is a dividing error. You may have had an instance where you saw a bunch of number signs or hashtags in Excel. That just means that the number was too large to fit in the cell, and you have to make the column wider. With respect to exception handling, the most common errors you might see are a quotient error, which is, that means you're dividing by 0. The quotient exception means you're dividing by 0. Anything divided by 0 is 0, which gives you an issue. You might have advantages by using exception handling. It enables a method to throw an exception to its caller. Without this capability, a method must handle the exception or terminate the program. In other words, it's either handled or the program does not run correctly as you've programmed it to or written it to. By handling input mismatch exception, your program will continuously read an input until it is correct. So, say you define a variable as int. With an input mismatch exception, you put in a string as your input, you put in a double as your input, you put in an int as your input. The programs keep going to ask you for input until you have that specific input type that is needed. In this example, int. There are also a number of exception types. You will have a class not found exception, input-output exception, runtime exception, such as an arithmetic exception, a null pointer exception, can't find it, can't find the information, index out of bounds exception. You might have elements, 10 elements, and the index is 0 through 9. If you're trying to find the index 10, there's nothing there. It's out of bounds, as well as illegal argument exception. There are different types of errors you might also see, such as linkage error and virtual machine error. They just will terminate the program. The exception will describe the errors caused by your program and any external circumstances. They can be caught and handled by your program, which is what we'll be doing on Thursday, solving some of our common exceptions and how we can resolve them. Runtime exception caused by programming errors such as bad casting, accessing an out-of-bounds array, and numeric errors are all mentioned here. Arithmetic, null pointer, index out of bounds, illegal argument. Runtime exception and error and their subclasses are known as unchecked exceptions. All other exceptions are known as checked exceptions, meaning that the compiler forces the programmer to check and deal with the exceptions. Runtime errors may occur when a program takes too long to run or compile as well. So in most cases, unchecked exceptions reflect programming logic errors that are not recoverable. For example, a null pointer exception is thrown if you access an object through a reference variable before an object is assigned to it. I mentioned earlier what an index out of bounds exception would be. Unchecked exceptions can occur anywhere within the program. You see highlighted here the most common unchecked exemptions. Arithmetic, null pointer, index out of bounds, illegal, linkage error, virtual machine error. When you're declaring, throwing, and catching an exception, you first need to declare your method. Method 2, throws exception. You've declared the exception. You then need to throw the exception. Throw new exception. Last but not least, you have to catch the exception. You have to figure out how to resolve the exception once it's thrown, which is the point of exception handling. You're invoking the method that throws an exception. You've declared it, you've thrown it. Then you catch it. In other words, if you're dividing by 0, you now need to figure out a way to resolve that issue. So again, IO is short for input-output. In this example, you're declaring an exception. Public void my method throws IO exception and some other exception. You're declaring your exception type, just as we showed you earlier here. Method 2 throws exception. Same idea here. When the program detects an error, the program can create an instance of an appropriate exception type and throw it. This is known as throwing an exception. So the exception X equals new exception, throw exception. Just as you saw earlier, throw new exception. When you put it all together, in this example, we're setting a new radius. Public void set radius double new radius. Throws illegal argument exception. In this example, our radius cannot be negative. If a negative number exists, there's an issue. Our new radius has to be greater than or equal to 0. It prevents any negative number by providing an associated warning. The more exceptions you prevent beforehand, the less possibility of errors. So that's why, in this example, we're utilizing 3 different possible catches. These possible statements might throw an error, so you try each of them, and then you try to catch each of them. Handler for exception 1 will try to resolve the first possible exception. Handler for exception 2 would try to resolve the second exemption, and so on and so forth. Here's another example. In the first example, we have the main method. We're referring to method 1. Then we're referring to method 2. Then we're referring to method 3. And we'll see this more when we get into stacks. You'll notice here it's a call stack where each is being stacked on top of each other. If an input file does not exist, an exception is thrown. So in this example, if a file does not exist, throw an input-output exception, file does not exist. So you may have instances where you might want to import data from a file on your computer, website you find online, etc. If the programmer does not set it up where the information is properly programmed to retrieve that file, you might have a file exception, just like this. Try catch is similar idea to if and else. Try, if there is an error, you catch it. So try to find an error. If it exists, catch it. Otherwise, just move on. In this example, you're used to make sure an exception is caught if missed the first time using throw. So we try to find an exception, and then we catch it. However, if it's not found, we then throw the exception. The finally clause will close the file whether exception occurred or not. So we try to find it, we catch it if it exists, otherwise we just complete our task as we need. So in this example, we're supposing there's no exceptions in the statements. So there's nothing to catch. Finally, next statement. The final block is always executed. The next statement is the method that is executed. But if we suppose there's an exception of type exception 1, it would be thrown in statement 2. What that means is we're now trying 3 different exceptions, and statement 2 is now being caught as an exception. And that catch, handling X, is how it would be handled. Then the final block would be executed. Then the next method is executed. However, if it now throws a different kind of exception, our next block of code we've added now, catch exception 2 example, would now take care of it. You'd see it would handle the exception. Then it would move on to the final, but it would then go back and throw the exception, just to make sure that it's been handled and taken care of. But there is a caution when using exceptions. They do take up quite a bit of computer resources. You may want to know when you want to throw exceptions. So an exception occurs within a method. If you want the exception to be processed by its caller, you should create an exception object and throw it. If you can handle the exception in a method where it occurs, there is no need to throw it, however. So here's an example. Remember that null is empty or missing. An exception here is thrown if the value is missing. Null pointer exception. We don't have a variable. We don't have a string. There's nothing there. It's missing. Since this is a simple exception, an if-else statement works best. So if your string is not null, print it out. Otherwise, give the error that the variable is null. You'll be able to define custom exception classes using the exception classes in the API whenever possible. These are all available online, and we import them as needed. Assertions are another way of handling exceptions. An assertion is a Java statement that enables you to assert an assumption about your program. An assertion contains a Boolean expression that should be true during program execution. Assertions can be used to assure program correctness and avoid logic errors. So think of an assertion as something that may or may not be true. Tomorrow it's going to be sunny out. We can check that within our programming code. So you define or declare an assertion, assert assertion, or assert assertion, detail message, where assertion is a Boolean expression, true or false, and detail message is a primitive type or an object value, like an int, a double, a Boolean, etc. When an assertion statement is executed, Java evaluates the assertion. If it's false, an assertion error will be thrown. Just the opposite of the primitive type where Boolean is set to be false. With an assertion, we assume that it is true. In this example, we're checking if I is 10 and sum greater than 10 and sum less than 5 times 10. This will throw an exception. I is always going to be set to be less than 0. So if we assert that I equals 10, we'll have an exception. Java always continues to update for ease of use. It's much different in 2023 than it was way back in 2003, as an example. You can disable an assertion once you've addressed an exception. So our exception handling, once we've handled an exception, we may no longer need to handle that exception, so we can move on. You may use exceptions, handling, and assertions together to address all your types of issues. But an assertion should not be used to replace exception handling. Exception handling deals with unusual circumstances during programming execution. Assertions are to assure the correctness of the program. As you saw before, we know from our for loop that I is always going to be less than 10. So if I equals 10, there's something wrong. We messed up. You don't want to use assertions for argument checking in public methods. You should rewrite this type of code using exception handling instead. You just use assertions to reaffirm your assumptions. Even strong programmers still use exception handling and assertions to double check their work. In this example, we're using a switch because the switch will check all cases. The file class allows input and output to be placed in a file. I mentioned you might have information you want to retrieve from a website. You can create a program that will create a file that will put that information in there. That utilizes the file class. You only manipulate files if they are yours and can be fixed. In other words, you might have a copy of it that you can change up and modify. You don't want to take somebody else's work and manipulate it. That could get you in legal hot water. So you might look through your file properties as an example. A file object encapsulates the properties of a file or a path, but does not necessarily contain the methods for reading, writing data from or to a file. In order to perform input-output, you need to create objects using Java appropriate input-output classes. The objects contains the methods for reading and writing data from or to a file. This section introduces how you write them. As you've seen previously with the scanner class, we can get input. With the print writer class, we can produce output. Writing data using print writer. Initially, we create a print writer for a specified file, whatever our file name is, :string. Then we write a string, or we write a character, or we write an array of characters, or we write an int value, or a long value, or a float value, etc. The print line method acts like a print method. Additionally, it prints a line separator. The line separator string is defined by the system, r/n, as you've seen previously. Sometimes you might want to, or you don't close the file, you forget. You can use a try with resources syntax that automatically closes the file for you. So you've wrote a bunch of information into it. Now you need to close it. You can create an exception handler to close it out, close that file. Reading data using scanner is similar to obtaining text input from the user. In this example, we're finding a source. It could be a file. It could be information you find online. Here's an example of how that might work. If you're connected to the internet, you can even read data from the web, commonly done with XML files which have data within them. So you, as a client, go onto the web browser or the application program, have to have connection to the internet, which connects to the web server, which has the local files stored on them. Think of when you go to Wikipedia to try and find information you might not know. You could necessarily take that text from the web. Here's how you would do it. URL equals new URL. And in this example, we're taking the website of Google's index. You create a URL object. You use OpenStream method defined in the URL class to open an input stream and use this stream to create a scanner object as follows. Scanner input equals new scanner, URL.OpenStream, which now creates an object with that text input. Now, on Thursday, we will go through a number of common exception handling types in our programming lesson. As you'll see, the most common is usually input-output and dividing errors. We will touch on them. And then you will have a required assignment associated with that where you are going to create your own exception and write in a specific comment that basically tells us that you know what the exception is and how you would go about handling it.